Welcome to the Animal Free Labcast, everyone. I'm back today with Dr. Gemma Davis. Hiya, Gemma.
Hi, Carla.
We have got a packed episode today, haven't we? What have we got coming up, Gemma?
Yeah, absolutely. We're going to be joined by Professor Delibegovic and Dr. Sarah Kamli-Salino from the University of Aberdeen, who are going to be telling us all about their amazing funded research using human-specific methods to study diabetic kidney disease.
Fantastic. Oh, really looking forward to hearing from them in a minute.
Yeah.
But tell us, we've had a busy couple of weeks, Gemma, so tell us what's been going on.
Yeah, absolutely. Well, we'll start by talking about our amazing drop-in event that we had last week in Parliament. So this was a drop-in event for MPs about Herbie's Law. You might have seen that we were asking you to email your MP to ask them to come along. And we're really happy because it was the best event we've ever had, biggest attendance. We had 42 MPs and peers come along to the event. So it was really busy. It was fantastic. We had lots going on at the event. We were also joined by broadcaster and animal welfare campaigner Kirsty Gallagher. So it was really great to have her along. And we also had 5 of our funded scientists come to talk to the MPs all about their amazing research. So that was Professor Julian Marr from City St George's, University of London. Dr. Laura Sinclair came all the way from the University of Exeter from our Animal Replacement Centre of Excellence. And we also had Professor Kenny Linton, Dr. Adrian Biddle and training research technician Josh Abram, who all came from Queen Mary, University London. So it was really good to have them all there to be able to talk to MPs and tell them, directly about the amazing work that they're doing to replace animals. I also had a little science station where we had a really fun activity for the MPs to do. So they were sort of doing my little pipette challenge. So that was just a bit of fun and a bit of hands-on. They really did. They were all getting really competitive trying to outdo each other. So that was really funny. And the main thing that we were asking people to do was to sign up to our Herbie's Law supporter list. So to put their names and to say that they support Herbie's Law. And we're really pleased because our list of supporters is now over 170 MPs and peers. So it's really fantastic.
Yeah, really
absolutely.
Good.
And we were briefing everybody ahead of the debate that took place yesterday to make sure everyone was really passionate and informed to go into that debate. So do you want to tell us a little bit about that?
Yeah, so there was a debate in the House of Commons yesterday. So this was about a petition that Camp Beagle put forward. It was on ending the use of dogs and other animals for the development of products for human use. It received over 121,000 signatures, which is amazing. Wow. So yeah, huge thanks to everybody who signed that and to Camp Beagle for organising it. Really strong cross-party support from MPs for ending animal testing in the Westminster Hall debate yesterday. There was 29 MPs speaking, which is really great. It was absolutely packed. Herbie's Law and our APPG on phasing out animal testing were repeatedly highlighted, and Herbie's Law particularly is the clear route forward for ending animal testing, and MPs really reflecting the significant public pressure to act. So the government responded, and whilst they acknowledged the alignment that we all have with the goal for phasing out animal use, once again, they did stop short of making firm commitments. That's frustrating because so many of us now want to see this happen. There is a growing momentum, and especially with the recent expose on animal testing in UK labs that colleagues in Animals International got into the public from a whistleblower. So you may have seen that. It was very distressing. And that has really raised serious concerns. And there was lots of mentions of that in Parliament yesterday as well. But I think what this does is it all just reinforces the need for us to keep on pushing for faster and more ambitious change. And I know it can sometimes feel discouraging, and we feel that too as well. But on the plus side, I would say momentum really is building. There's 170 MPs. I mean, it is a significant proportion of the 650 MPs that are in the House of Commons. So I do think momentum is really building. So thank you all for lobbying your MPs. Thank you for signing the petition, and thank you for supporting the scientists who are making a real difference on the ground in the labs across the UK.
Yeah, absolutely.
And we're going to talk to 2 of them in a minute, so really excited to do that. But before we talk to Mirala and Sarah, Gemma, last week's Mythbuster, myth or fact? Sorry, that is terrible. I can't help it though. What was the answer? The myth was, or the fact was, There are important scientific questions that can only be answered through animal research. Is that a myth or a fact? What did our listeners think?
Yeah, well, it's a very good question. And actually, 97% of people voted myth. So 3% of people said fact. And almost everybody was right. It was a myth. So, this is quite often we hear from scientists that they have to use animals because it's the only way that they can study whatever disease it is they're working on. And, while that might have been true in the past, possibly there wasn't different ways to study everything that we can now. The technologies that we do have now, things like organ on a chip and complex cell culture methods like organoids and things like that, they really are coming on in leaps and bounds. So whereas that might have been the case, a few decades ago, it's probably not the case now. And if you look into the scientific literature these days, you can see things like organ on a chip really are being used to study literally everything. And these are being really developed. They're becoming more complex. Things like adding in a blood supply, adding in immune cells and combining different cells from different parts of the body, all to make them more human specific and able to give us better results about what is going to happen in a patient compared to an animal. So,
and Gemma, didn't you say earlier that we even now have big toe on a chip?
Yeah, well, that's
funny.
it. Literally everything is being studied. So that is a bit of a joke that, we have big toe on a chip. But in theory, if you did want to study a big toe on a chip, you could combine things like muscle cells and all the different cells that you would find in a toe, which would be different to different parts of your body. So, this really is the way that people are focusing their research these days. So I wouldn't be surprised if in future there is a big toe on a chip. But to take this even further, the opposite is true. There really are important scientific questions that really can't be answered through animal research. And that's because a lot of diseases are uniquely human, meaning they can't even be modelled in animals. So a good example of this is Alzheimer's disease. So for decades, scientists have been trying to make genetically modified mice to study Alzheimer's disease. But even though there's now lots of different types of genetically modified mice that you can buy or create yourself, none of them can actually replicate both the symptoms and the full disease progression that we see in humans. So quite often they'll end up using a couple of different types of mice to try and then combine that data to understand what's going on. So clearly that's not going to give us the whole picture of what's happening in a human. And it's a big reason why we don't actually have any really effective treatments at the moment. And it's just one example where we really do need to look at different ways to study this to make a massive difference for patients. So
Absolutely.
That's the myth there. So thank you to everyone for voting. We also have had a few comments in the podcast poll box about the last episode where we were discussing the toughest questions that have come through. A lot of people were really interested in the conversation around AI. So, for example, Paul left a comment saying AI is the way forward. Everything else is now a Victorian approach with testing on animals. Naomi says, my nephew does medical research using AI. I wish more was done this way, and I think it's very important to save animal lives. And then Dora says, I was brought up to believe that animal testing is the only way, but now I believe with so much advancing in research, it's the animal research that is wrong. However, I think AI is a risk to our existence, so I am concerned about this. So
it's such a hot topic, isn't it? Yeah. And
absolutely.
I think there are many people trying to figure out kind of how good is the AI and how far can it take us.
Yeah, exactly. But used in the right way, it can be really powerful. So let's see what comes in the future.
Absolutely.
So let's chat to Mirella and Sarah. Thank you both so much for joining us today.
Thank you so much, Gemma and Carla, for inviting us here today.
Yes, thank you so much for the invitation. A real pleasure to be here.
Oh, thank you.
And it was super
on.
interesting also kind of listening to your introduction as well. That was kind of a nice overture to what we'll be talking about going forward.
Thank you.
So thanks.
Well, you are the scientists doing this every day on the front line. So we're really delighted that you're here and can't wait to hear more about the fantastic specific animal-free work that you're doing, which benefits patients and benefits animals. So yeah, tell us more.
Yeah, so the core of our project is to develop a drug testing platform using kidney slices that we will obtain by processing biopsies from patients. So straight from the hospital to the lab.
Oh, fab.
And yes, and the idea behind that is that this technique has been developed using animal tissue, of course, but it is also used using human biopsies. For example, it has been developed using livers. I know it has been developed using lungs, and it is also in the development for kidneys. And why kidneys? It is becoming such a rising problem. And it was before, but it was more silent because we are interested in diabetes and the complications of diabetes, and one of them is kidney disease, but it is quite silent, and there has been a huge focus on the eyes, the cardiovascular system, the skin, especially with foot ulcers. But kidneys have been a little bit pushed aside for now. It was something on its own, but now there was an emerging awakening regarding kidney diseases related to diabetes. So that's why now it is the time to do this, because there are treatments available, but ultimately patients will go through transplantation and dialysis and then ultimately to transplantation. So there is a need for treatment, and it has to be now.
So basically, the background that you gave earlier on about different models of Alzheimer's and different mouse models of Alzheimer's really recapitulates the picture in studying kidney disease. So there is basically no perfect animal model to study a kidney disease or what may be going on in a human body, right? And people have tried different crosses, as you said earlier, kind of genetic crosses, pharmacological induction of kidney disease, but you can't recapitulate that kind of long-term exposure, for example, in diabetes, not just the long-term exposure to high glucose, high sugar levels, but you've also got the state of inflammation that's going on in the background, and all of these things are kind of working in concordance to damage the kidney to the extent that the patients will then go through dialysis, kidney failure ultimately. So what we're trying to do in the project is actually take it now out of that kind of animal model, but also kind of stepping away from just cell culture models. You said earlier, Gemma, that, organ on a chip. I mean, there are massive debates still on organ on a chip. Yes, you've got one cell type, you've got another cell type, but in the body, you've got so many different cells and so many different things happening, but we've got to invest in new technologies to understand it better. So rather than just studying things in mouse models or cell culture models, what we're wanting to do is, can we take a slice of a human kidney that's going to be discarded during surgery anyway, because normally patients that are undergoing kidney biopsies do have an underlying condition, but there's always going to be a part of the kidney that is quite a healthy kidney. So can we use that to actually study it and see in a person what may be happening? Because in this kind of technology where you've got a slice, you've got every cell type, every kind of thing that may be going on in the body. Okay, maybe you won't have bloodstream contributing to it, but that's something we can develop further if we start from the basics.
This is so fascinating, because I think, just going back a little bit, when I think about diabetes, I think about the pancreas, and I think about my little dog from years ago, bless him, he had diabetes and he lost his sight. So I think about that, and ultimately he died of liver disease. So I think about liver. I don't think about kidneys, but yeah, like you said, Sarah, it's a sort of a silent thing then, maybe.
It is, especially because diabetic kidney disease is being developed through 5 stages, and the first 3 ones takes years, and they are the silent ones. It's very hard to pick up, and because they are hard to pick up, we don't have a full understanding of the actual progression. So that is why it's important to enhance the research, especially using human tissue, so that we can have a better understanding. And as you said, we tend to think about different kind of tissues and not the kidney. So
yeah.
And it's interesting that you say pancreas, because, of course, when we think about type 1 diabetes, this is the failure of pancreatic beta cells, being destroyed basically by the body, by the autoantibodies. But when you think about diabetes, it might not be just type 1, diabetics. It's people living with type 2 diabetes and other complications. And in many cases, that kind of long-term exposure to all sorts of factors that we discussed earlier is going to lead to that kidney failure. And like Sarah said, we don't actually have appropriate diagnostic tools that can tell us early on what goes on. So by the time you know, it's too late.
And just to add up on this, because we're talking about type 1 and type 2 diabetes, so with the type 1 being the type of diabetes where you would need insulin injections to manage the blood sugar levels. With type 2, it is very hard to manage. We can do through medications, but ultimately there is a problem. There is a miscommunication with the action of insulin. And actually, with diabetic kidney disease, the prevalence is much higher in type 2 diabetes rather than type 1, because with type 1, first of all, it's detected very early in most of cases. And all the symptoms or all the potential problems can be alleviated through insulin injections, while type 2, because it is very often not managed at all for years. This is where this will lead to diabetic kidney disease. So it's mostly, not only, but mostly a type 2 diabetes disease.
And Marilla, I think it's really fascinating what you were saying about the organ slices, the little slices of kidneys that you're taking, because I mean, we talk about organ on a chip a lot on the podcast, don't we, Gemma? And it is used as an example a lot as this is the thing, this is the technology that is going to have a lot of the answers to replacing animals. But you're right, they're still quite simple models, aren't they?
Yeah, absolutely. And, you know, we all know that there is a big push towards kind of by 2030 across the European Union of not having animal research or trying not to do research in animals as much as possible. But that has to kind of come hand in hand with development of new and better tools.
Absolutely.
Right? So like you talked about organ on a chip. One of my favorite ones is organoids, right, themselves. So we started developing liver organoids, for example, about 8 years ago with a clinical fellow who is a gastroenterologist, and she wanted to develop mini livers. And that's beautiful because, again, people will be undergoing biopsies, and then we can get a piece of healthy liver tissue that we can then kind of nurture and give us some growth factors so that they can start growing up, in effect, mini livers. But again, it's not just the liver that is a problem, right? You need those stellate cells, you need endothelial cells, you need macrophages, immune cells, a combination, but you've got to start from something. Yeah. So when you start with something and then you start doing combinations and then adding on some cytokines, this is when you can start recapitulating that damage. And this is exactly what Sarah's trying to do in her project. Instead of a single organoid, she's actually going to do the slice. So you've got the medulla, you've got the cortex of the kidney, you've got different parts of it, so that you're not just studying a single structure. And first of all, we can see how well they survive in culture. We know from liver slice technology that they survive for a few days. And then we can also then stimulate them with different factors that we know are circulating in circulation. And then that should hopefully kind of mimic that diabetic milieu much better.
It's absolutely fascinating, isn't it? It sounds,
really is.
it really does make a lot of sense, like you say, to be able to involve all the different types of cells. And it just takes it that step further to being more realistic of what's happening in your body. So when
but
you've got
to
these,
start somewhere, right?
That's
So
it.
this is why these pilot projects are amazing, because they actually give the kickstart to do it.
That's it. And you can build on it. Absolutely. So once you've got those slices, up and running in culture, what do you plan to do with them?
Oh, many things. So first of all, it is to establish a proper model at the university, and also making sure that all the knowledge that we have can be used for the human slices. It would be used, of course, but it is just to make sure that the model is fully established and fully screened, so that we know what we are working with at the start. And then, so it will go through basic cell culture research at very first. So I will have the slices. They will be maintained in the culture media, and then they will be collected and they will be analyzed. So we will do histology to see structures, if there is difference in structures, just normal slices, or if we expose them to high glucose, for example, or other kinds of stressors. We also want to see if there is difference or changes in gene expressions, especially in gene targets that we know are which we know they have a key role in the development of diabetic kidney disease.
What Sarah's trying to do, as you say, like do normal physiology. Does it look normal? How long does it survive? Do the structures look right? Can we stimulate it with high glucose, normal glucose, to see that things change like they would in diabetes? Then some pro-inflammatory cytokines like TNF-alpha, all these things they would normally have in circulation if your body is going through a disease or pathophysiology process. But then the idea is really to set it up as a drug testing platform. So rather than testing drugs in mice, like you said earlier, if there's a new therapy or established therapy, and instead of injecting mice and seeing how they respond to it by taking out the kidney, you can actually use the kidney slice technology, expose it to different drugs, different alterations of that drug, because it may be that you got to kind of change the formulation of it. But then you can also do dose responses, all these things that normally you would have had to do in animals. You could, in theory, if this works, and it will work, you could just do it in kidney slices. You can see that if you stimulate with a drug that is meant to be anti-diabetic, things that are heightened with high glucose levels should be normalized, and that's your readout. And the idea would be for any new drug that is coming around, it could be used as a screening platform. You just use these kidney slices that we collect and get from the hospital, normally several kidneys a week, and basically we culture them and then we just screen different drugs. So that's the idea behind it.
So how far away do you think you are from being able to do that? Because that sounds very exciting.
Oh, we're right at the beginning, Carl.
Yeah.
But maybe Sarah, you want to tell them that, during the PhD, part of the PhD was that companies, pharmaceutical companies, different companies around the world will be using mouse kidney slice technologies. So the idea is actually that is already established elsewhere. So the idea would be, hopefully we can use similar kind of technologies that are published to set it up for the human kidney.
Right. Yeah, which is so important.
But Sarah, how long do you think it's going to take you?
Oh, a week, of
No
course.
pressure.
No, it actually takes time, because it's not only the experiment itself, it is all the background work before that, making sure that everything is in place. First of all, the protocol, of course, but ethics and also all the discussions to make sure that we can get the biopsies, that we will get the right biopsies, and that we can do all the work we need to do with them. So there is a lot of background work for this. Discussions with health and safety, whether it is for the use of specific reagents, or because in this case we will be using oxygen to keep the tissue alive longer so that we will have the best outcome possible. And something that we don't necessarily think about, vaccination. We are using human tissue. We have also to protect ourselves. So everything takes time in the background. But now we are ready to welcome the biopsies. So everything is in place on our side and also at the hospital side. We just need to get the right patient and the patient who actually would gladly donate.
So this project, the pilot project, is funded for 8 months. And as Sarah said, you started 1st of March, right?
Yes.
She spent most of the time in March and April getting all the ethical approvals, collating with the biorepository, with the research nurse that would be recruiting our patients, consultant that would be collecting the kidneys. making sure that all these conditions are set up, having this oxygen, etc. But the idea is by the end of 8 months, what we're hoping to have is a viable slice that can stay in culture for several days and not die out. Right, so it can live there for a few days, and then we can test some of the kind of positive controls so that we know some of the drugs like metformin for type 2 diabetes, for example. So, if we do slice technology and we stimulate it with cytokines, high glucose levels, etc., then if we start adding different doses of metformin, we should be normalizing that. So that's a positive readout. So hopefully within these 8 months, this is what we would be achieving. And then that would give us kind of the basis to seek further funding so that we can actually then start incorporating, what if we can add other cell types into this? How closely would this mimic it? Maybe we can use plasma from patients to also include in that. So all sorts of kind of things that can be tested.
Oh, this is all so fascinating. We could talk to you all day, but very quickly, our last question for you both. Why is it important to be doing animal-free research? Why have you chosen to go in this direction with your work?
For me, the key driver is to avoid unnecessary suffering. It is really my key driver in this project. Of course, I'm an animal lover. I might be a scientist, but I am an animal lover. And it is, of course, always heartbreaking to see how they can be used, the way they can be used. And although we are, of course, always trying to improve everything, and we are bound during animal experimentation, for example, by the 3 Rs: reduce, refine, replace. These projects will help with all 3 Rs, and this is the key driver.
From my perspective, it is about kind of moving towards precision medicine. So no single person is the same, as we know. So what works for you and me might not work for Sarah and Gemma, for example. So the idea would be, when we going forward, is that hopefully if people are really sick, that you could actually kind of test within the same individual what may be the best treatment for them. So, there are a lot of new drugs on the horizon. So Sarah spent her whole PhD working on synthetic cannabinoids as potential treatment for diabetic kidney disease. But wouldn't it be lovely if we knew that in some individuals that might work, but in some individuals actually that doesn't work because their cannabinoid system is not altered whatsoever, but what they have is an alteration in a different signaling pathway, and for them something else would work much better. So from my perspective, it's definitely the 3 Rs, but it's also making everything really patient specific and driven towards that precision medicine way.
Well, it's the win-win-win, isn't it? It's the win for animals, it's the win for patients, and it's the win for science. So, yeah, we're so proud to be supporting your work. It's absolutely fascinating. And thank you so much for coming onto the podcast and chatting with us.
Thank you so much for inviting us. And we do look forward to kind of updating you throughout the project as well, how things are progressing. And hopefully when we speak in 8 months' time, we will have achieved things that we are hoping to achieve. But if we haven't, please don't judge us, because we're going to be working towards it. It's a long road ahead.
That is so true.
It's a long road, but it's the right road. So we look forward to inviting you back in 8 months and talking more about it.
Thank you, Carla.
Yeah, thank you so much for joining us.
Well, that's all we've got time for in this episode, but we'll be back in a fortnight when we're going to be talking all about our first ever community event in Scotland. It's being hosted in Glasgow. So we'll have absolutely loads to tell you about that and how it went. We've got, I think, something like 70 scientists coming, so very exciting. But before we go, Gemma, I'm going to sing again. So bad. Tell us this week's myth or fact.
Yep. So this week's question is myth or fact: regulations require animals to be used in every area of research. Myth or fact? So that's regulations require animals to be used in every area of research. So you can vote on our website, and you can also find the link in the podcast email that comes out on Thursday, and also in the links on our social media. And I'll tell you the answer in the next episode. If you've got any questions or you'd like to get in touch about anything else, please do drop us an email at hello@animalfreeresearchuk.org, and we might feature your comment in a future episode.
Brilliant. Well, thank you so much for listening. That's all we've got time for, and we'll see you in a fortnight. Bye for now.
Bye.